In lesson 4, we're going to talk about a couple new things. We're going to talk about angle-angle side proofs as one of our new patterns, and we're also going to talk about CP/CTC, which is an extension off of our proof statements. So for the first one, they give us some givens, and they tell us to prove the triangles are congruent. So this is more along the lines of what we've been doing. The only difference is, again, we're going to be working with a new pattern here. So we still start with our statements and our reasons. No matter what, our first step is always going to be our givens. So BC is perpendicular to CD, AB is perpendicular to AD, and then angle 1 is congruent to angle 2. And all that stuff is given to us. I'm going to take real easy. I'll take angle 1 congruent to angle 2. I'm going to mark it. Now we can see those are outside of the triangle. So I'm just going to hold off on those for a second. And I'm going to first deal with my perpendicular pieces. So if BC is perpendicular to CD, that means we're going to have a right angle at C. And they already used 1 and 2, so we are going to call this angle 3. And then usually we talk about our perpendiculars together. So AB is perpendicular to AD. That's going to put us down here at angle A, and that's 4. Remember, perpendicular takes 2 steps. Angle 3 and angle 4 are right angles. And the reason for that is perpendicular lines form right angles. All right. And then right after that piece, we can always say that since all right angles are 90 degrees, we know that they're all congruent to each other. So step 3, angle 3 is congruent to angle 4. All right angles are congruent. So there's going to be one of our angles that we're going to use in our picture. Next, we're going to go to our angle 1 and angle 2. Whenever they are located outside of the triangle, that is usually a good giveaway that we are going to have supplementary angles of some sort. So for step 4, angle 1 and our next angle in here would be angle 5, and then angle 6 right underneath. So remember, if two angles are congruent, and they both have supplements, their supplementary angles must also be congruent. And we're also going to take this in 2 steps. So angle 5 is supplementary to angle 1, and angle 6 is supplementary to angle 2. And the reason we knew that is because they were angles. Let me make that a little bit more clear. We're going to have angles on a line, right? Angles on a line are supplementary. So then in step 5, we know that angle 5 is congruent to angle 6. And this is going to come right off our proof statement chart that we have at the start of our packet. Congruent angles have congruent supplements. So again, if angles are supplementary to each other, all right, and they are congruent, and you have 2 sets of angles that are congruent, then their supplements have to be congruent. So there's another angle. So now we are out of givens. So there's only one piece left for us to look for, and that's either vertical angles or reflexive. I see that side. In step 6, I see BD is congruent to BD. That's going to be our reflexive property of congruence. And now if I look at my picture here, there's a side. I have angle, angle, side, and angle, angle, side. Remember, this is not angle, side, angle. You can't start counting at angle 3 and skip this side and angle to get to another side. You have to go to the next closest thing. So that would be angle, angle, side, and angle, angle, side. So our 2 triangles are going to be congruent. BCD is congruent to triangle BAD. And we're going to be angle, angle, side. For our second proof, we're still going to be working with angle, angle, side, but we have to identify the fact that our proof statement is different. Now again, we are trying to prove that AB is congruent to CB. We are not given it, so we cannot assume it. But we have to notice that AB is located in our one triangle and CB is located in the other. So we have to first identify the two triangles that are going to end up being congruent. So before we do that proof statement, we're going to have to prove that triangle ABD is going to be congruent to triangle CBD. And again, we're going to have to make sure we match up the letters in that statement since we have to write it ourselves to make sure that we have the correct congruent pieces. So to get to that triangle part, it's going to be the same exact thing we've been doing. We're going to list our givens, we're going to get to one of our patterns, and then we will do our extension from there. So BD bisects, now notice it's angle ADC that's being cut in half, and then they gave us angle A is congruent to angle C, and that's given to us. So the nice part is here, angle A is congruent to angle C. That's just something we mark. There's an angle for us already, so we're going to move on from that piece now. The next part we'll talk about is our bisect piece. So remember, we are bisecting the angle only. That's the only thing that they told us is being cut in half. So if angle ADC is being cut in half, that's going to give us those two pieces, 1 and 2, that are congruent. Angle 1 is congruent to angle 2. A bisector divides an angle into two congruent angles. And there's another angle for our pattern. So now we are out of givens. So therefore we either have to look for vertical or reflexive. I see a reflexive side at BD. So BD is congruent to BD. Reflexive property of congruence. So there's a side for us. So what do we have? We have angle, angle, side, and angle, angle, side. So we have to make sure that we prove that our triangles are congruent before we state that AB is congruent to CB. So triangle ABD is congruent to triangle CBD, and we use our pattern, angle, angle, side. Now, once we've proved that those two triangles are congruent, all of the non-marked corresponding sides and angles are also going to be congruent. So that's how we're going to finish this proof with our proof statement, which is AB congruent to CB. And our acronym is going to be CPCTC. Corresponding parts of congruent triangles are congruent. So remember, once you prove that two triangles are congruent, all the matching pieces that have not been labeled yet are also going to be congruent. And that's how we'll finish this proof.